Lists are a way Python stores a bunch of stuff together. We've encountered variables. There comes a situation where a variable, say something like Adam equals Adam, maybe Victor equals Victor, and etc. I think you get the point. Where variables are just not enough, and you probably want to store something in more than one location. So a list is one nice way. So we can have maybe a quick shopping list that we can use to store the fact that we should be buying apples, maybe tomatoes, or tomatoes, however you pronounce it, or maybe oranges as well. Yeah, so this is the syntax we can use to write a list. Okay, we can print out our list, and voila. To access elements in a list, we use what we call an index. So for example, we can maybe print out the shopping list and access the 0th index. You may be wondering, but 0 is how most Pythonistas start to count. And you can think of 0 as the distance between the first character or the first element in a list. So apples, of course, has a 0 distance to itself, whereas tomatoes has a distance of 1 away from the first element. So if we wanted to access tomatoes, we can do that. That gives us the value for tomatoes, and we can do 2 to get the values for oranges. Okay. Python is referred to as an object-oriented programming language. So that means we can do certain things to this list. For example, we could sort this list, and then when we print out that list, it's kind of sorted out. A for apples is like the first character, oranges. So this is like in an ascending order. We could also reverse this list the other way around. And then when you do this, you can see tomatoes starts first and apples ends last. Okay. There's a nice handy method, an inbuilt function in Python that can be used to generate lists. And in our case, let's generate a list of numbers from 0 through 100, but not including 100. So we'll look at that shortly. So 0 in this case is the starting point for this list. And when we print out numbers, you'll notice that we started counting at 0, but didn't include 100. Okay. So we're going to do a bunch of things to these numbers. We're going to do an operation called slicing. So slicing is a way to access a bunch of stuff. We can slice this thing from its 0th element to maybe its 5th element. Okay. The 5th element in this case is less by 1. So we'll start counting from the 0th item in the numbers list, the first item, the second item, the third, and the 4th item, which coincides with the value of 5 minus 4. And to put this in perspective, it's like we're going through each one of them, slicing them out. We can put this all in one line so that we can get the perspective of what's going on. And voila. We do not include the 5th item because the syntax just stops us there. Okay, so this is our list of, in this case, it's a tuple of numbers. But I think you get the point. There are certain things that happen with lists. So I'm going to create another list. And okay, we can print out X, and then let's have another one. Let's say Y. So we have X, and now we can reassign the values of X to Y. So let's do something. Let's say we can print out Y and we can print out X. But what happens if we say add something to the list X? And in our case, we can use a method called append. Append is very useful for adding stuff. So let's add 4. What do you think will happen to Y? Think about it. When we print out our X, our Y probably might be changed or not. So let's print it out and see what goes on. It's changed as well. So there might come a time in your coding where you want to copy a list to another list, This reassignment that I'm going to show you, or mouse over here, usually doesn't do the trick. If you want to do what we call a deep copy, you have your X, and let's say A, we want to copy this all to A. We can do something like that, okay? And then we can have our A values and our X values. And when we add, say, another character into X, say 5, and we print X, you'll see that R5 has been added. But when you try to print A, it still stays the same. So this is a small gotcha to watch out for. There's several things we can do to our list. We can remove the last item. That's through the method called pop. So this is a way we call methods onto an object. X is an object, and this object is just a list. We can insert stuff, or we can remove particular values. So if we look at X again, we can say remove the value 3, and when we print X, 3 no longer exists. We could also insert values in specific positions. So the first argument in insert would say, let's say they placed a value of 2. We want to insert maybe the word replace. And when we print X, you'll see that X goes in the position of 2 here. So 0, 1, 2 kind of replaces it. So there's several methods that you can apply to lists. One nice one is maybe my favorite. It's called the map method. It's an inbuilt method, and it can be used to apply functions to something. So let's say we designed a function that returned a square of a particular number, say n. So I'll use a shorthand. So we can test it out quickly. So that's like 3 by 3. This is odd. So let me rewrite this. Return n to the power 2. So when you get that, should be 16. Right. Nice. So let's say we have our list X. So we're going to remove that because it will affect us. When we print X, we can use map to map a particular function. So in this case, we put like a function callback, which does nothing. You don't have to call the function, and then map it to the value of X. So you notice what happens. The function squares out the items inside of X. Okay, but of course that doesn't change anything in our previous X. But if you want to change it, we can say squared values of X, and then we can print out that variable. Voila, there you are. Well, thank you for exploring lists with me. I hope this helps you clear out a bunch of things you may have.